Hello guys, welcome back. Today I will discuss the rest of the questions of the JEE Advanced 2025 paper 1. So this is the first numerical type question. I had discussed up till the multiple choice in the last video. So going with this question, I will read it out once. Let the set of all relations R on the set ABCDF such that R is reflexive and symmetric and R contains exactly 10 elements. So we are to find the number of elements in this set S. So basically this is a very simple question. So if we take the set S as A, this contains A, B, C, D and F. So now this is very fundamental theory that if we find out the total number of elements in A cross A, so there are 6 elements, so basically it will be a total of 36, which is 6 squared. So I will try to write out A cross A. So if we write A cross A, it will contain all the elements from starting from A comma A up till F comma F. So there are 6 elements. So in this particular part there are a total of 6 elements. And because we have 36, so rest of these elements will be a total of 30. And actually this is the part where the manipulation will occur. So this part will actually contain all those elements like A comma B, B comma A comma C, and again C comma A and dot dot dot, like all the elements that can be formed. So basically the condition for this question is that we have to find out all those elements which will be reflexive and symmetric altogether in the set S. So if we take R, I'm sorry, this is the real number sign. If we take R, it will contain the 6 elements at first, which is mandatory, and secondly we have 10 elements, it is bound, so basically there are 4 elements left here. So for this to be reflexive and symmetric, if you notice carefully, we have to take the elements pairwise. For example, if we take A comma B, we have to take B comma A as well. If we take A comma C, we have to take C comma A as well. So basically if we divide 30 by 2, we have 15 pairs and only 4 places. So each pair contains 2 elements. So basically out of these 15 elements here, we can select only 2 pairs for this place. So the answer basically will be 15C2, which if we calculate, this is 15 factorial by 13 factorial into 2, which is, I guess, 15 into 14, 13 factorial gets cancelled, and this is 2. So the answer for this first question is 105. This was a pretty simple question. So we will now move on to the next question. So basically this is the next question. This is from vectors. So as we can see, we have a triangle PQR. I will draw that. This is roughly the triangle PQR. This is a rough diagram. This is PQR. And if we take, we have the vectors SP vector, SQ vector and SR vector. So basically what I will do is, if say this is the point S, okay, I will take this to the left hand side. Say this is the point S. Okay, and if we join this point S to P, Q and R, so basically what I am saying is I will write this as small p vector, this SP vector, SQ vector as the small q vector, and this as small r vector. So basically if we rewrite this equation in these terms, we have p vector plus 5q vector plus 6r vector equals the 0 vector, which is here. This S is the 0 vector. So after this we have that P, Q, R are 3 distinct points, and E and F are the sides which are E and F are the midpoints of PR and QR. So if we take PR here is E, and let's say here is F. Now if we join EF, as you can see, I will mark this in the diagram. This is the midpoint of this side. So basically now we will use something that most of you might have learned in class 10th. This is actually midpoint theorem, which states that if we join the midpoints of two sides of a triangle, then this joined line will be actually parallel to the third side. And also mod of EF vector, I'm writing this in vector form, this will be half of mod of PQ vector. This is something which I guess most of you might know. So yeah, JEE Advanced is also asking questions from class 10th. That means actually every concept matters. Anyways, we will proceed. So what we have to find is modulus EF vector by modulus ES vector. So basically, if we notice, this E is nothing but P vector plus R vector by 2, and F is nothing but Q vector plus R vector by 2. Now if we are to find EF vector, so basically if we subtract these two vectors, so R vector will get cancelled, so it is basically mod of P vector minus Q vector by 2. And if we are to find ES vector, so S vector is basically, I'm writing this for clarity, S vector is basically R0 vector. So ES vector will be basically E vector, which is P vector plus R vector by 2. So I guess we can't reduce this like this. Okay, we will use this result. What we will do is we will substitute in place of P vector, we will substitute minus 5Q vector minus 6R vector if we take this particular thing to this side. So let's substitute. I guess after substituting we will get minus 6Q minus 6R vector, because here we have a Q, and I guess here there will be one R vector, so it will be minus 5Q vector minus 5R vector. So basically from here, if we take minus 6 and minus 5 out, so the negatives will get cancelled, and Q vector minus R vector whole mod is also getting cancelled. So basically the final answer is 6 by 5, which is 1.2. This is the final answer. So basically this question was very simple, but if you guys don't remember midpoint theorem, maybe it will be difficult. So now we will proceed with the next question. Okay, so this is the next question. This question was a fairly good question from permutations and combinations. I will read it out once. Let S be the set of all 7-digit numbers that can be formed using the digits 0, 1 and 2. So basically we have to use only these 3 digits to solve our problem. And now in this example they have said a very simple thing, that 0, 2, 1, 0, 222 is not in S. So basically this is common sense, because if we have a 0 in the first place, then it will be a 6-digit number. So yeah. Now we have to find number of elements X in S such that at least one of the digits 0 and 1 appears exactly twice. Now this means we can have the following categories actually. At least one of the digits 0 and 1 appears exactly twice. This means that either 0 will appear exactly twice, or we can have 1 appearing exactly twice, or we can also have 0, 0, 1, 1 appearing. These are the, I guess, 3 possible cases. Now if you guys look carefully, one very nice conclusion from this is this 0, 0, 1, 1 will actually come somewhere in between these two cases, because this will be counted in these two cases. So basically we have to subtract, we have to first add the combinations we get in these two cases and then subtract this particular part from this sum, because this is being counted twice here, so we will subtract it once. So now let's proceed with the question. Okay, so here are 7 places. So first I will consider 0 exactly twice. So I will consider a very simple case, because we can't have 0 here in any case, as it will become a 6-digit number. So basically we will have either 1 or 2, so I will not worry about this. So we have, I guess, 6 places here, out of which we will choose any 2 places for the zeros. So out of these 6 left places, we select any 2 places. And now this, from here we have 2 places gone. Say I select this as the 2 places. So we have 3 plus 1, 4, and another place here. So 5 places in total. And in these 5 places, as we have already placed 2 zeros, we have 2 combinations, I mean 2 selections left, that is 1 and 2. So we have a total of 2 power 5 choices. Now proceeding with the next case, if we again draw this, now we will get the next case where 1 is appearing exactly twice. Now here we can have 2 cases. I will draw this once again. Now here either 1 will appear here or either 2 will appear here, because 0 is already not in the field. So in this particular case, if 1 appears in the starting, then we only have 1 left. Now say I put it here. So basically out of these 6 places, we select only 1 place, and as in the same manner as we selected 5 places here, we will again have 2 power 5 choices. And in this particular place, we have to select, say I place the ones here, we have to select any 2 places. Now one thing which I want to be sure of is that these two ones may not be aligned next to each other, they can be adjacent also. Okay, that's very obvious. Now 6C2. Now this has been done, and we have already ascertained that this place is filled with 2, because we are considering that particular case. So we have 1, 2, 3, and 4 places, which is 2 power 4. So this is the sum total. Now I will try to calculate. I don't have space here. So let's take this to be, say, x1, x2, and x3. I will try to calculate this. Okay, so these are the respective values for x1, x2, and x3. We will calculate this in the last. I'm not finding the values now. Maybe it will cause some easy calculation. Now let's come to this particular case. So for this case, this is actually where the sum gets critical. We will have 7 places. Now if we look into this case carefully, 0, 0, 1, 1 has to appear together. So either there will be 1 or there will be 2 in the starting, like this. So let's say I put 0. Okay, so 0, 0, 1, 1 is actually appearing together in this case, so I guess we will put it in a box. So the thing is, out of these places, whichever place you select, it could be this, maybe it could be this. So whichever 4 consecutive places you select, you have to keep this in a box. So basically, if we select 4 places from here, we are left with 1, 2, and 3 places. So we will give 6C2, because, okay, 6C2, because here 1 is already fixed. We are considering the case, and 4 places are filled, so we have 2 places left. So 6C2. And for this particular, we have 4 factorial, and from similar terms, we will divide 2 factorial 2 times. Now for this particular case, we will have 6 factorial by 3 factorial 2 factorial. I will explain why. Because here 2 is already fixed here. So 0, 0, 1, 1 will be arranged within these places. Now there is another one also. So basically 6 factorial is the total number. Now 3 ones, so 3 factorial, and zeros, so 2 factorial. Because if you notice carefully, in whichever fashion I place 0, 0, 1, say I place it like this, 0, 0, 1, 1, these 2 places can be filled either with 1 or 2, because you can't use 0. So if we place 2 here, say 1 here, so we have 3 ones. So basically 6 factorial by 3 ones, so 3 factorial and 2 factorial. So I will do the calculation for you guys. So here is the calculation. I have added these. Actually I took 16 common from out these, so it's 30 plus 12 plus 15, and this will come out to be as 90 minus 60. So this is basically 16 into 57 minus 150, and on calculation this comes out to be as 762, which is the correct answer for this question. So basically this question was not very difficult, but this part was a bit complex. And most of the people, the mistakes you guys will commit is you will consider this case but will forget this. Because even I, while doing this question, I forgot this particular case, and later when my answer wasn't matching, I will be honest, I realized that this case was forgotten. So be pretty careful in the exam hall. So yeah, we will proceed with the next question now. So let's proceed with the next question. So this question was a very simple one. From limits, we just have to use L'Hopital and do it. Now there can be also two procedures for doing this. I will show you while doing the questions. I will write down the question first. So this is the question. So it's pretty obvious that in the first step we have to apply L'Hopital's rule. So if we differentiate this will come out to be as 1 by 3x square alpha by 2, and this will become, I guess, 1 by 1 minus x square plus beta. Keeping cos x constant, this becomes beta cos x, and on keeping x constant, this becomes minus beta x sin x equal to 2. So now from here what you can basically do is either you can, I'm not doing that, I'm showing only one procedure. You can differentiate this further using L'Hopital's, and you will get something of this sort, that alpha by 2 plus beta equals to 0. This will come as one equation, and after differentiating it further, I guess around 2 steps, you will get another equation, and solving them you will get the values of alpha beta, and then you can put them and find out your answer. But I will employ a different method in which we will actually get alpha plus beta directly. So let's see. So what I will do is I will put cos x and sin x as expansions in this particular equation. So I will put that. So this is what it comes. Now if we go to, like, take this 3x square inside the bracket, this will come out to be like something like alpha by 6x square into 1 minus x square plus beta by 3x square minus beta by 2. And now what I will do is we will have another term here, minus beta x square by 18 equals to 2. What I am doing is, because we already eliminated the higher powers of 4 here, although this had a power 5 and this had a power 4, and I guess if we when we take the LCM, this will become an x power 4, which I guess is unnecessary in this particular question. So I will directly use the limit and put this to 0. So now we will try to manipulate this. Okay, so before proceeding further in this question, this important result I will write it down, and I will also show how this is coming. So basically if we multiply this 2 into 1 minus x square here, and if we substitute x as 0, we will basically get this alpha plus 2 beta, or you can actually derive this from this part also. I'm not doing this because it's a waste of time, you guys already know. So this is the result that we are getting. Actually this will be pretty useful later on. I will show you how. So after manipulating this, we took the LCM, and after manipulation, here we are getting this alpha plus 2 beta term, which was already 0, so I put it to 0, and here I divided this x square above, so it came out to be minus 5 beta plus 3x squared beta by 1 minus x square. Now if you substitute x tends to 0 here, you will actually get beta equals to as minus 12 by 5, and now we have the second equation, where if we put the value of beta, we'll get it to be as plus 24 by 5. So what we are required is alpha plus beta, which will come out to be as 12 by 5 or 2.4, which is the answer to this question. So basically this question was not difficult, but yeah, what you can do is you can also go for L'Hopital from here, but I guess this process is less lengthy as compared to L'Hopital. It will take a lot of your time in the exam hall. So yeah, let's proceed to the next question. Now, this question was a very good question and a cool question in my regard. I will show you how, just a minute. Okay, so here in this particular question, the first thing that you can notice is that the function f of x is greater than 0, and it will be because f of x plus y is equal to f of x into f of y. Now, this is something that you guys have learned in functional equations. So basically, we have to take this function f of x as a small a power some kx. We will find the values later on. Now, other information that is given in this question is we have some numbers. Now, please regard that A1, A2, these are all different. This is not same as this. Up till now, A1 till A50 is an arithmetic progression. I will take the common difference to be D, and the first term is A1. So now the condition given is that f of A31 is equals to 64 times f of A25. So if we put the values in place of x, if we put A31 and A25, so basically this will come out to be a power k. Now A31 will be A1 plus 31 minus 1, so 30d, which is equals to 64 into f of, sorry, it's not f of, it's a power 64 into a power k into A1 plus 24d. So basically, if we take this power to the left side, these powers will get subtracted and we will have a power 6 kd. Now 64, as you guys know, it is 2 power 6. So from here we can easily say that a is 2, and on comparing we get kd as 1. So now we will proceed to what is said further in this question. So this is the condition which is given in this question for us to find k and d maybe. So as you guys can notice, this is actually a sum of these a power kx's, which will maybe form a GP, as you guys might guess. So we will write this down. So this is it. Now this is the form that is coming. Now if we take a power ka1 common from this, we will have 1 plus a power kd plus a power 2 kd up till a power 49 kd. So basically, as you guys can notice, this is a GP whose first term is 1 or a power 0, you can say, and the common difference, the common ratio is a power kd. So I will write that down. So this is it, a power k1. And because 1 to 49 means, because a power 0 and a power 49, so there are 50 terms, so a power 50 kd minus 1 divided by a power kd, which is the common ratio, minus 1. This is equal to 3 into 2 power 25 plus. So now before proceeding, what we will do is we will derive a result from this part. Because 6 and 6 are common, we can actually write a power kd as 2. So now we will move back to the question. So now we can write a power k1, and now above we have found that a power kd is 2. So basically we can write this as 2 power 50 minus 1 by 2 minus 1 is equals to 3 into 2 power 25 plus 1. Now if we factor this particular expression, this will be 2 power 50 plus 1, 2 power 25 plus 1 into 2 power 25 minus 1. So we can strike this out and bring this here. So I'm writing it down. This is 2 power 25 minus 1. So finally 2 minus 1 is 1. So we get a power k1 as 3 divided by 2 power 25 minus 1. Now we will proceed with the last result. So this is basically what we are required to find. So this is f of a6 plus up till f of a30. Now there are a total of 30 minus 6, 24 plus 1, 25 terms here. So basically this is also a GP. I will write it down. This is a power ka1 plus 5dk plus a power ka1 plus 6dk up till a power ka1 plus 29dk. So what we can do is we can take this particular factor common. So we will be left with 1 plus a power kd plus this will go on up till a power, I guess, if we subtract 5 kd, so this is basically, just a minute, so this comes out to be as a power 24 kd. Now the sum is actually done. So this particular part, a power ka1, we have found it to be 3 divided by 2 power 25 minus 1 into, now a power kd was 2, as you might remember, so this is 2 power 5, and inside the bracket we will again have a GP series of 25 terms because this is a power 0, so 2 power 25 minus 1 by 2 minus 1, so this and this gets cancelled, this is 1. So basically your final answer is 3 into 2 power 5 is 32, which is 96. So this is the answer to this question. So this was a pretty interesting question and pretty simple one. Now let's move on to the next question. So this is the next question. So this question is actually a very good question. Now what will happen is, as is pretty obvious, we have to solve these three differential equations, find out y1, y2 and y3. And now most of you, what you will do is you will actually go on finding the constants, but what I will recommend is don't find them because you will know later. So let's solve this down. So this is the first differential equation. This is pretty easy to solve. If we take this to the right hand side, then integral dy1 by y1 is integral sine square x dx. So we will write this as 1 minus cos 2x divided by 2 dx, and now we will have ln of y1. Now I am not putting a mod here because in the limit it's all x tends to 0 plus, and also in the question it is given for all x greater than 0, although you can put the mod, no issues. So this will come out to be as 2x minus sine 2x by 4 plus, let's take the constant as lambda 1. Now if we solve the second differential equation, this is dy2 by dx minus, okay, I'm taking this to the right hand side, y2 cos square x, so this will become integral dy2 by y2 equals to integral, we can write cos square x as 1 plus cos 2x by 2 dx, so the result will be ln y2 equals to 2x plus sine 2x divided by 4 plus some lambda 2. Now for the third differential equation, if we solve dy3 by dx equals to, now 2 minus x cube by x cube, if we divide this will come out to be as 2 by x cube minus 1 into y3. So integral dy3 by y3 is integral 2 by x cube minus 1 of dx. So what we will basically have here is minus 1 by x square, because if we differentiate this thing, we'll actually get 2 by x cube minus x plus some lambda 3, and here we have ln y3. Now why I am asking you guys to not find out the constants is because if you observe the question carefully, e power 3x sin x is there in the denominators, and actually if we substitute this ln, like if we take e powers on this side, so the pattern comes to be something similar, because e power y, we will have y1 as an e power function, and 3 e power functions will actually add up to something. So we will try writing that out, and I guess we don't have to find the constants for some reason. Let's see. So this is basically our y1, y2 and y3, and now this is the result that we are required to find. So what I will do is, as there are e powers multiplied, I will directly add them up. So if you add all these powers, you will notice that plus sine 2x and minus sine 2x get cancelled, and there are two x by 4s, so it's simply x and minus 1 by x square plus x. Sorry, that's not plus x, it's minus x. And okay, I forgot to write the e power, and I'm writing out e power lambda 1 plus lambda 2 plus lambda 3 as separately, plus 2x divided by e power 3x. And now as limit is x tending to 0, so we can directly replace this with x, or as you guys know, I will just write it out. This is sine x, so we will basically divide x and multiply x. I just said that we can replace it with an x, so this and this gets cancelled. So basically we have this as the final form. Now for some time I am taking this to be a constant k. So this is the final form with the constant k. Now the thing that we should observe here is e power 3x will, as x is tending to 0, so this will anyways goes to 1. Now if we put 0 here, then x is approaching infinity, but as you guys might know that e power minus 0, so e power minus infinity will tend to 0 faster than what infinity does. It's e power minus infinity. So basically if this approaches 0 faster, this will take this also with itself, and this will make this whole thing 0. And that's why we actually don't need to calculate the constant. If you guys did this question in the exam hall and found the constants, it would maybe take around 5 or 6 minutes of your time, where you could actually devote and complete another question. So basically the final answer of this question is 2. So this was a pretty interesting question. So this is the target of basically JEE Advanced. JEE Advanced will give you constants and many other things that are useless. We will see in the upcoming questions also, which are actually meant to lose your time. Okay, so we will proceed to the next question now. Okay, so here is the next question. I guess this is the simplest question in this entire paper because there is nothing to actually think about. It's all just calculation, and you guys have to solve this. So what I will do is I will just take out the equations and solve maybe 2 options, and the rest of it I will leave it to you guys, because the next questions are more important than this. This can be done just using calculations. So let's start off with the question. Now the sum of the frequencies here is 19, so f1 plus f2, and if we add the others, this is 5 plus 2 7 plus 2 9 plus 3 12, which is equal to 19. So basically we have our first equation, f1 plus f2 is equal to 7. Now what I will do is I will just draw the table, because I guess we need to calculate the cumulative frequencies. So xi, we have to arrange these in ascending order. So this is 4, this is 5, this is 6, 8, 9, 11 and 12. Now here we will write down the frequencies. This is 5, this is f1, this is 1, this is f2, this is 2, this is 3, and this is 1. Now we have another information that the median of this frequency distribution is 6. So as we have, I guess if we add up f1s, the sum of the frequencies is, I guess, 19. So as you guys know, 19 plus 1 by 2, the 10th term will be the median. So basically it's not 10th term actually. We have to find any term, I guess. As you can see, I guess this should be the median. Anyways, we will calculate. We have to actually find out a term whose cumulative frequency is either equal to this or greater than this. So we will write down the cumulative frequencies first. So these are the cumulative frequencies. Now after this, if you add 6 plus f1 plus f2, actually f1 plus f2 is 7, you know that. So we'll directly write this down. This will be 6 plus 7 13 plus 2 15 plus 3 18 and plus 1 19. Okay, I guess, okay, this is not 19, this is 20. Yeah, so that's it. Now what we will basically do is, as we know 6 is our median, so we can easily say that 6 plus f1 is 10. So basically f1 is 4, from where f2 is 3. So basically 7f1 plus 9f2 will come out to be as 28 plus 9 3 is 27, which is 55. So it gives you p as 5, but we can't ascertain anything from this because it's in ABC all. So we have to find out further, I guess. Yeah. So we will try to find out the median of this distribution. So median is basically x bar. Now if we add all of this, I guess this will come out to be as 133. I've calculated this, divided by the sum of the frequencies, which is 19. So x bar is 7. So we will make another column here, which is xi minus x bar. Now for xi minus x bar, we have to just subtract all of this from 7. So this will become minus 3, minus 2, minus 1, 1, 2, 4, and I guess this is 5. So we are required also to find out the mean deviation about the median, which is alpha. So we have to add this up. On adding this up, I guess, okay, it's not enough. Not only xi minus x bar, we actually have to make another column. I will make it for you. So here is the column for fi into xi minus x bar. Now what you should do is you should actually write these columns on the side, because I'm having lack of space, so I'm not writing that. So if we add up this will come out to be as 48. So basically what we need is alpha, which is sigma fi of xi minus x bar. Okay, this is actually mod of xi minus x bar, as I have not taken the negative signs, divided by sigma fi. So this is basically 48 by 19. And now what we are required to find is 19 alpha, which comes out to be as 48. So Q comes out to be as 3. So basically we are shortened down, and if you look at A and C, you will actually have R as 2, so you don't need to calculate that. 19 beta will come out as 47. Although I can calculate it for you guys, but I guess I will leave the calculations to you guys. And for sigma square, what you can do is just sigma fi square by sigma fi minus mean square. So you already know the mean here. We get 49, and I request you guys to find out this, because calculations will take a lot of time. So this question is nothing but, okay, and our correct option here I will tell you. So the correct option here will be basically C, because S, this thing will come out to be as, I guess, 146. So I leave the calculation part to you guys. This question is basically very simple, and if you actually know to eliminate the options, you don't have to calculate R. Although I guess, no, beta is not required. You actually don't require beta to calculate this. So you save maybe about 5 minutes of your time. So R is already there. What you have to calculate is just S. So you should also know to eliminate options in such questions. Okay, that's it. I will proceed to the next question now. Okay, so here is the next question. Now, in this particular question, when I solved, the option elimination was quite easy, but I will solve all the paths because this is a good question. All the paths are actually good questions. So let's go with P first. Now, in P, if we notice, this is actually some f of x, which is given as, I will take this inside function as g of x by n, because g of x is basically 10x cube minus 45x square plus 60x plus 35. So basically I will just differentiate this to find out the critical points. So we get it as 30x squared minus 90x plus 60, which you can take out 30 common, and you will have x square minus 3x plus 2, which I can factorize as x minus 1 into x minus 2. So basically if you guys notice, here is 1, here is 2. Now if you guys notice, there is no negative sign, so this is basically a curve which will come like this. Now this thing, this is minus infinity, this is plus infinity. Now this thing in between 1 and 2, that is the interval in actually which we have been asked the question. In between 1 and 2, this function is actually decreasing. It's a decreasing function in 1 to 2. I'm talking about g of x. So basically what we will do is I will try to find out g of 1 and g of 2. So if we find out g of 1, it is 10 minus 45 plus 60 plus I guess 35. So this comes out to be I guess 70 minus 30. Okay, no, not 70. This comes out to be 60, yeah. And this will be 80 minus 45 foza is 180 plus 120 plus 35. So this will come out to be as 55. So basically the need for finding this out is actually we want to know where the range of values for this function g of x is lying so that we can find out n. So I will do that. So if we finally write down f of x, it's boxed in between the values 55 to 60 divided by n within the box. Now to find out the greatest integer, as the question reads the minimum value, we have to find the minimum value of n for which this is continuous in this interval. Now for this function to be continuous, as this is a box function, if we take an integer such that it occurs at two separate integers, then there will be a break in between because there is a box. So what we have to do is we have to find the smallest integer where this thing will be continuous. So we have the options with us. So first what I will do is I will put n equals to 5. If we put n equal to 5, I guess this comes out to be as 11 to 12. So this is two different integers, so this will not work. Now if we put n equals to 6, in case of 6 also I guess it will not work. This is coming out to be 6 9s are 54, so 9 point something and 10. So no, this is also not working. After this we have n equals to 8. So if we put n equal to 8, this is coming out to be 8, I guess 6 point something, and this is 7 point something. So yeah, again not working. Now when we finally put n equals to 9, I guess this will be the answer. N equals to 9, we are getting this as, for 55 it is 6.1 something, and for 60 I guess it is 6.6. So yeah, this is actually continuous. So we have been asked the smallest value of n. So I guess this will be 9. Now you can do the same for 10 also. 10, it will work for, I guess it will work for 10. I guess no. Anyways, we need the minimum value of n, so it is n equals to 9. So for P, the correct option is 2. Now we will move on to the next option. So we got P as 2. Now I will try to move on to the next part. So in the next part of the question, we have a function g of x, which is 2n squared minus 13n minus 15 into x cubed plus 3x. So basically this is a function of x. Now this particular part, as is obvious, this will always be greater than 0. So if we factorize this, this will come out to be as n plus 1 into 2n minus 15 into this particular thing which is greater than 0. So if we look into this particular part, this is lying in an interval of, I guess, minus 1 to 15 by 2, which is 7.5. And the graph will go something like this because it's fully positive. Now we are required to find the minimum value of n for which it is an increasing function. So basically this will be to the, obviously, to the right hand side of 7.5. So the nearest integer to the right hand side of 7.5 is 8. So our answer for this part is 8. This was pretty simple. So for Q, the answer will be 3. Now going on to R. Actually, R is also pretty simple if you think. H of x is x squared minus 9. I will write it out as x minus 3 whole power n into x plus 3 whole power n into x squared plus 2x plus 3. This can be written as x plus 1 into x plus 2. So basically this particular part is always greater than 0, as is obvious. So now if you look at x equal to 3, because we have been asked as the smallest natural number n which is greater than 5. Now I guess I will take 3 because it's a natural number, so we can't take minus 3 anyways. So the graph, if we try to graph this, this will be something like this. Now what is pretty obvious is that if we have to keep the function increasing, then we have to keep both sides positive. That's pretty obvious. So on these two sides we have 2, we have 4, but now we have to look at the options because they have set the smallest natural number n which is greater than 5. So basically I guess the answer will be 6 because it is greater than 5. So for part R, the answer is option 4. We will move on to the final part now. So this is the final part of the question. So we have to find all those x naught belonging to R such that this particular Lx is not differentiable at x naught. So basically this involves a concept that maybe all of you have learned if you have studied LCD. If I put these values, we'll actually get this to be something like sine of mod x plus cos of mod x plus half plus sine of mod x minus 1 and dot dot. Now if we look at this particular segment of the equation, sine curve looks something like this. So mod sine x, sine of mod x, I'm sorry, it will look obviously something like this. So it is not differentiable. This is very simple stuff, you guys know. And cos of mod x plus half will also have a graph something similar to this because whatever inside positive or negative doesn't matter, and mod is already there. So this particular thing is as a whole not at all differentiable. So if you guys keep putting mod x minus 1 and x minus 2, you will eventually find that for all the x naughts varying from k equals to 0 to 4, it's not differentiable. So basically the number of x naught we have been asked here, so basically x naught will be 4. So I will tell you the answer. Okay, I'm sorry, I made a mistake. This is not 4 actually, 0 to 4. So 0, 1, 2, 3, 4. 0, 1, 2, 3 and 4. So it's 5 numbers. So the final answer is P2, Q1, R4 and S3. So I guess it's option B. Now what is striking in this question is, I will go to the option elimination part. If you guys actually find out P2, you will find it's 2 in B and D. And after that, if you can find either Q or R correctly, you actually don't have to solve two parts, which saves most of your time. I solved these parts because it was a pretty good question. But if you find either PQ or PR, maybe you can find PR, or actually you can, okay, P is 2 repeated, so I guess you have to find this. And amongst Q and R, if you find anyone, you can go for R if it seems simple, or even Q. Then you can actually eliminate solving any two options and you will get the answer immediately. So yeah, now let's proceed to the final question. So this is the final question of this paper 1, and basically this was actually a very interesting question because not only is it interesting, it also involves the concept of vector triple product, so you need to know that. So basically we have a vector W vector. Okay, just a minute. So basically we have a W vector which is 1 1 and minus 2, and now it is given that U cross V is W. I will write it down. And also v cross w is u. This actually means that all these vectors are actually mutually perpendicular. So amongst these three vectors, if you choose any two, that means I guess 3c2, you have three ways. So if you choose any three dot products are possible. So if you choose any dot product out of these, you can actually know that all of them will come to zero, whether it's u dot v or it's v dot w and so on. All of these will come to zero. So now we have a set of questions. Now, so before proceeding with this system of equations, what I will do is I will take this equation and I will substitute the value of u vector from here into this particular equation. So what we will have is v cross w crossed with v again is equals to w. So this is vector triple product, as you guys might know. So if we do that, this is v into v, so mod v squared, and outside we will have w vector minus with w dot v vector with v vector, which is equals to w. Now this is where the magic lies. This thing is zero because the dot products are all zero as they are mutually perpendicular. So if we now move w vector to this side, we'll have mod v squared minus 1 into w vector equal to 0. So from here we get that mod v squared equals to 1, which is basically the first part of this question, I guess. So p comes out to be 2. Now if we move on to the next part of the question, if we find out, okay, if we find out u dot w, because what I intend to mean is, as we have these three equations given, alpha, beta, gamma and t, we have four unknowns but three equations. So I aim to find out another one, so we have four unknowns and four equations. Now u dot w will be alpha plus beta minus 2 gamma, which is basically 0 as the dot products are 0. So now if we write down the other set of equations, I will write it down for you guys. Okay, so this is it. Now if you can actually observe in this particular question, you will find out that alpha, beta, gamma and t are real numbers. Now alpha, beta and gamma can't be 0, because if we find out mod w from here, it is root 6, and if you put root 6 here, it is a non-zero value. And basically if we also observe here, if we take mods on both sides, u can't be 0 at all. So alpha, beta, gamma have to be non-zero numbers. So basically the thing which I am trying to say is that we have to find, this is actually a system of equations where we have to find a non-trivial solution. So basically that's what this question demands from you. You take these three equations and find the values of t. So we will do that. So this is it. If we write this non-trivial solution, then the determinant of this particular thing here will be 0. Now what we can do is we can solve it in either way. One thing which we can do is, because this is 0, we can actually consider this top row, and as per cyclic order we can say that minus t plus 1 will be 0. So one value of t comes out to be 2, because we will have another value. I will show you how. Now if we look into this carefully, if all the rows and columns in this particular determinant are identical, and as you know, if that happens, then by property the mod will be 0. So if you observe carefully, this is only possible when t is minus 1. If we put t as minus 1, all the terms are 1. So basically this will come out to be as 0. So we have two values of t. Now here is where the question becomes a bit complex, because as we have two values for t, we have to solve them out separately. And we also need another equation which we will get from v cross w equals to u. I'm sorry, this is v. If we take mods on both sides, we'll actually have mod v into mod w equals to mod u. I'm not taking sine theta because as the dot products are 0, the angles are already 90, so I've not taken sine theta. So this is root 6, and this is root alpha squared plus beta squared plus gamma squared. So basically we get another equation from here, alpha squared plus beta squared plus gamma squared equals to 6. Now we will try to manipulate the values of alpha, beta and gamma for these two values of t. So I have put the values of t as -1, and this is the final set of equations. Now if we add these two equations of, we'll immediately get gamma as 0, and when gamma is 0, from this equation we will get alpha is minus beta, so we can directly put that here. And now gamma is 0, so 2 alpha squared will be 6. So basically alpha will be plus minus of root 3, and from here we can also deduce that beta will be minus plus root 3 because alpha is of minus beta. Now we will look at the options once. So if you look at the options now, alpha is root 3 given, so we have already found that alpha is plus minus root 3. So from there gamma squared will be equal to 0. So basically after p was I guess 2, after p q will become 1. And if we want to find r, beta plus gamma squared will automatically become plus minus root 3. Beta was minus plus root 3, so it is minus plus root 3 squared, which is 3. So r will become 4. Now actually I don't even have to solve s, because if you find out you can easily eliminate the options and get the answer, but we will still do that. Now alpha root 2 will actually occur because there are two options for two solutions for t, so it's pretty obvious that at t equals to 2 we will have, because this all of this q and r was obtained at t equal to -1. So basically at t equals to 2 we will have alpha equals to root 2. That's pretty obvious. So the answer will be anyways s as 5, but I will still solve it out for you and find out the values. So if we put t equals to 2, then we will have the following equations. We will have -2 alpha plus beta plus gamma as 0. We will have alpha minus 2 beta plus gamma as 0, as we can see here, and alpha plus beta minus 2 gamma as 0. Now from these equations, if we subtract this and this, what we will get is minus I guess 3 alpha plus 3 beta is 0. So basically alpha is equal to beta. And also when we put alpha as equal to beta, we'll also get gamma is equals to alpha. So basically all of them are equal. So yeah, and finally we'll get alpha as plus minus root 2, because we have this equation. This is also applicable here. So as alpha, beta, gamma are all equal, so we will have 3 alpha squared as 6. So automatically alpha is plus minus root 2. So we can match option S as well. So this was it. This was a very interesting question. If you guys are preparing for advanced, you should practice this question because it involves vectors as well as system of equations, which is a very important topic in my regard. So yeah, this is all for today. And I guess I have missed out one question in paper 1, which is from LCD, that x squared sine 1 by x question. I will try to bring it out in the next video, or if you guys want I will make a separate video on it, or what I will do is I will actually include it in my paper 2 video. So yeah, I will bring it out surely, don't worry. So thanks for watching guys, and that's all for today. Do like, share and subscribe. Thanks for watching.